When we bring this rod there, on your paper, did you draw this? Okay, well, make sure you do that. Oh, wait, you need to go to the nurse. Okay. Draw this out, and I want you to draw the electric field around that rod. So draw the electric field around that rod. Do that now. These are all recorded, right? Put these in the box, return them, and then whatever, there's more stuff here. Oops, that's recorded. That's annoying. Hopefully, you drew something like this. Did you have something like that? Yeah. Okay, because negatives attract, right? The arrows go in, positives go out, negatives come in. Okay, I think I'm recording now. Is it recording now or is it recording before? That should be recording, right? Okay. So yeah, as Janelle said, all the charges, the electrons are going to be moving up and out of this wire. If that happens, what is this copper bulb going to do? Yeah, it's going to be partially positive on this side. And so it's going to be attracted to that rod. Okay? Does that make sense to everyone? Yeah. Okay, now, once it touches the rod, what's going to happen?
The negative in the ball is you go up the line.
Okay, so if this touches the rod, will the ball stick to the rod or will it just touch and bounce off? Okay. Yeah, so it's going to come over and attract, and then as soon as it touches, if this is a non-conducting rod, then where this touches, as Calvin said, a little bit of the electrons will jump over to here, but then they'll just leave. And then the rest of the electrons on this non-conducting rod are stuck. So they're still going to have this electric field. So as long as this is conducting and it's grounded, and as long as this is non-conducting, when it sticks, it'll just stay there.
Why did one leave in the first place?
The only place that charges can move are conductors. So if you have this conductor is in a very strong field, then the charges in the conductor are going to move. So when you put this very negatively charged rod close, that field causes all the electrons in the conductor to leave. Right? So that's how they moved in the first place. But this, I believe this rod was an insulator, or did they say? No, they didn't say. Okay, well, if this rod is an insulator, then once this touches, it'll stay because it can't suck all the charges on here. If this rod was a conductor and you touched it, then all this charge would go whoosh right through there, and then they would both become positive, and what would happen? Yeah, right? Oh, like it would pull apart. Oh, let's think about that. Yeah, wait. They would rush on. Actually, you know what? It would probably rush on until it became neutral. And then they would both be neutral and just separate and fall apart. So I don't think it would repel really far, just it would drop apart because it became neutral.
Would it take time or would it just happen like
it would happen pretty fast, like in an instant. Okay, but because this is an insulator, then it's going to come up and stick and stand there. Okay, now that's only because this is a conductive wire and it's to a ground. Now what I would like you to think about for a moment is what if this was an insulating wire? If that was an insulating wire, what happens?